Okay, right, we have to start with Heidi's talk now. So Heidi is technical group lead at Xero. Tonight he's talking to us about his experience of working on one of the product teams. So they each choose their paths, can choose their paths autonomously. So he worked with one of the teams to achieve a continuous delivery pipeline where a commit to production just meant clicking one button. And I'm assuming to undo it would be a button too. Who knows? Let's find out. Okay. There's two spare seats here up the front if anyone wants to be closer to the action. And we're going to break in about 40 minutes.
All right. Thank you all for coming in today. So as Shirley said, so I'm Hardy and I've been at Xero for about 3.5 years. If you want to take this conversation outside, continue this conversation outside the presentation, you can reach me through my Twitter handle. Otherwise, we can always talk after the talk during the drinks. So today I really wanted to go and share a journey that a small team at Xero has been doing, working on a problem that we had, and we wanted to go and, like Shirley said, achieve continuous delivery. And in order to do that, we had to challenge a lot of things about the way that we do things, and particularly the way that we do testing. My background is I'm a developer, and I'm a staunch developer. I love development. But to do this work, I had to get into testing and wear the QA hat quite often and quite a lot. So I just wanted to go and share our learnings, and hopefully you can find some insights in our story. Now, before I start, I can't get rid of this thing at the top, but ignore the ask a question part. But before I start, I wanted to say that context is very, very important. So what I wanted to say is today's journey is to solve a particular problem that my team had at a point of time. There's many other teams at Xero that don't do things quite the way that we are doing it. You might be working in a company right now that is not enabled to do the work that we're doing. So I want to make sure that you know that what I'm talking about is not a thing that we did within a period of 6 months, but it's actually carrying on the work that many other people before me have come and done at Xero. So we've really got a lot of infrastructure in place. We've got a lot of the mindset in place, so we don't have to convince managers about doing things in an agile fashion or to take time to do retrospectives and refinement. This is already a given. And I've worked in many environments before Xero where I've come from a very traditional background of a corporate, working in a big monolith where things are the way that they are. So please don't want this to discourage you at all. If anything, hopefully there's some insights that you can take into your current role. The key takeaways that I'd love for you to walk out from, I mean, I'll be talking about a lot of things, but these are the key takeaways that I think I'll be successful if this is indeed what you take away from this talk. Number one is this concept of contract-driven testing, and I'll be talking to you a lot about it. Second thing is combining different testing strategies is essential for you to get good testing coverage, okay? And that's what the talk is about today. We don't just do one thing or two things. We did a whole lot of things, including delivering bugs in production purposefully to get good coverage or to discover that we've got problems in production. And the last thing is the also other important theme that I'd love for you to think about when you leave today is everybody is responsible for testing. The notion that testing is a tester's problem is the stigma that I want to go and break. It's everybody's responsibility on the team. Be it the tester, of course, the developer, the product owner, everybody's responsible for quality. So the story starts last year, I think around July, the business came in and said, hey, we want you to go and deliver this important feature for us. We didn't have enough teams to go and deliver the feature, so we decided to go and bring in contractors to Xero. The very first time they were bringing contractors. And I was asked to be sort of the gatekeeper, the person that sort of works with the team that gets hired, making sure that everything is up to Xero standards. And after the contractors leave, I become the person that inherits the work in a way. So it's the last bit that made me quite worried. I don't want to be the person that people come to when the contractors leave and they depart with all the knowledge, and I become the bottleneck. So I wanted to make sure that the project is in such a state that anybody from the company can literally read a couple of things and confidently contribute to the project and modify it with confidence. And that's the key, having a lot of confidence, working in this code base that they've never seen before, with some documentation, and not really come talk to me before they do every single change. So that made me think, and made the team think, that started forming, what can we do to start this green fields project? And what can we do from the scratch, from a technical aspect, from a non-technical aspect, from a culture, from a documentation perspective, from a mindset, in order we can, to deliver such a project. So we almost started thinking about this utopia, this beautiful land, this brand new code that we're going to be writing from scratch. What can we do so that I don't get buggered at the end of the project, and at the same time to make sure that we also deliver a quality product on behalf of our Xero customers. So the key point that we came to is we needed continuous delivery. Continuous delivery in such a way that at a press of a button, no matter what change you made, we will run through a pipeline of checks. And if every gate goes green, we will go all the way to production without asking anybody any more questions. So continuous delivery almost implies that there's a lot of practices that have to be in place in order for you to reach this particular level. A definition of continuous delivery is a series of practices that are designed to ensure that code can be rapidly, so very, very quickly and safely deployed to production, and delivering every single change. And the last point there that's also highlighted in orange is that this can only be underpinned by rigorous automated testing. Okay, so that's the philosophy of continuous delivery. Now, bear in mind, when I first started at Xero 3 years, we were not working in this manner at all. I joined, and I think we used to go and deploy code to production once every 2 months. So the entire company works on the same code base. Once every 2 months, we have an awful meeting before the day of go live. There's about 15 people in the room, us trying to figure out dependencies, who needs to go first. We need to come up with a rollback plan. We had a person working full-time just to go and manage the deployment process. It was a nightmare. So things have changed dramatically, and nowadays we deploy to production many times a day. Within half an hour, we could be deploying 2 or 3 times, and this is just one team. Okay. Now, we couldn't do this by flicking a switch. It took a while for us chipping at this monolith that we had, but I'll share with you some of the principles that we use. Now, again, so that we're all on the same page, continuous delivery that I just spoke to is the idea of writing some code, building a package, and that package goes through a number of steps, through milestones. So it goes through unit testing, it goes through some sort of platform testing or integration testing, it gets deployed to a staging environment, like a pre-production environment. It passes some acceptance tests that give evidence to the business that we've passed the requirements that they've asked from us. It gets eventually deployed to production, and then it goes to, and you can do some post-deployment steps. Everything happens automatically except the deploy to production part. That's the only part that is done manually. Now, there's another term that gets spoken about quite often as well, and I even get confused about it, which is continuous deployment. It's exactly the same, except continuous deployment is everything is automated end to end. Okay? A lot of companies might go to continuous delivery because of auditing reasons. They cannot trust a machine. A person pressing a button is not enough confidence for their stringent requirements. So they might require a special person, a gatekeeper, that is responsible for pushing whatever is ready to go to production. Okay? We've achieved the ability of having continuous deployment, but we've chosen to go with continuous delivery because we're not quite there as well. So we're not very, this is still a journey. We're almost there, but we hope in our next project to go to continuous deployment. Now, like I said, in order to achieve what I'm talking about, there's a number of principles that we had to go and embrace. And one of the key principles is working in small batches. And this is a movie that escapes me, but it's a guy called Philip Petit, who sometime a while ago did an incredible feat where he actually walked on the rope between the two trade towers. And while I'm watching it, epiphany came to mind, and I thought, this is exactly like development in terms of what he's trying to do, which is a great feat, going between one building to another. is the end goal. For him to do so, he can't run it. He can't just simply walk it. He needs to go and take a small step at a time. Now, the step is so small that if he feels that he's out of balance, he can take a step back. It's similar to development in a way. We do work in small batches. So for example, for a particular feature, we might start by adding a small button, and I might deploy that small button to production straight away. Now, to make sure that none of our customers see this incomplete feature, we wrap it behind a feature flag. So we basically say, if user A or user B from my team logs in, only they can see the incomplete feature. All of our customers don't get to see anything. But once you have that plumbing in place, the ability to go and deploy and isolate features in production, you can go and deploy an incomplete feature like adding a button and deploy it to production. And guess what? If it breaks, we know immediately what broke prod. It's that small button that we just added. And we can immediately undo the deployment that we did. Or in our case, we roll forward. We actually go and do another release where we remove the button that broke production. So in this particular case, what I'm trying to say here is he does small feats that are safe and secure. Every single time he does a small step, we run through a series of tests to give us that confidence that we haven't broken anything that happens. Now, because we're working on these small steps, the other thing is it's easier to manage. When somebody's talking to me about what they just did, they've just spoken about a small pull request, 2 files that got modified, rather than 2 weeks worth of work. Imagine the risk of 2 weeks worth of work, worth of testing, worth of reviews, and 2 hours worth of work that just went out live. It's much easier for us to even talk about and think about. It's easier to keep in your head. The blast radius if something goes wrong is quite small as well. And the other thing, for us to work in small steps, it actually demonstrates that we understand the goal and how we're about to get to it. So if we've got a team of 5 people and we're all not sure about the thing that we're trying to deliver, we wouldn't be able to go and work in small batches. So in order for us to work in small batches, our communication as a team had to improve significantly. We would make sure that we have a universal language, a shared language that everybody understands. Even the product owner understands exactly what we're talking about from a technical perspective. So once we all have a shared understanding, we can then start planning these minute pieces that we can go and deploy to production in small steps. The other technical practice that underpins the ability for us to go and achieve continuous delivery was having rigorous automated testing. And not just any automated testing, testing that gives us confidence. So I've worked with many teams with different abilities. I remember one of the teams that I worked with, we had a lot of tests. But when we did a small change and my tests passed, I did not have confidence that I did not break any existing functionality. And I had to ask one of my QAs to say, hey, do you mind if just quickly for like 50 minutes or an hour and a half, just run through these manual steps for me, just to make sure that I haven't broken anything else, even though I've got a test suite of 200 plus tests that just went green. So it tells me something that the tests that I've written are of questionable value. They pass, but then I don't know if I'm confident in them. Now, the reason, these kind of tests are tests that do a lot of mocking, for example. They simulate a lot of behavior that's not true behavior. They work on an environment that doesn't represent production. They integrate against, stubs or mocks, for example. There's a lot of reasons why your tests do not give you a lot of confidence. But we had a lot of those tests, and we wanted to make sure that we wrote automated tests that are quick to write, easy to maintain, and most importantly, give us a lot of confidence so that we can literally close our eyes, push the button, and deploy to prod without asking too many questions. Now, at Xero and the project that we're in, we work using what we call microservices. So we don't have any big code bases. All our code bases are really, really small. And all our code bases do one thing only. So this is what this is referring to as microservices, which is the opposite of where I used to work before, where we used to have a very, very large system that was inherited by a particular company. Xero used to be a monolithic application that would take, like I said, we would deploy once every 2 months just because of how big the code base is and how many people keep contributing to the code base. So we've gone through a phase of breaking all our work into microservices, and that immediately unlocked our ability to go and work independently, autonomously from each other, So I don't have to talk to any team in Wellington or in Melbourne or in the UK about doing a change. I'm completely isolated from any of their work. And I think that was one of the key things that helped us work with the cadence that I'm talking about today. Now, when you're working with microservices, the game has changed. Like I said, we've got these small components maintained by different teams that work remotely in different places. They scale and maintain in different ways. And each team is a guardian for these services. So with the shift to working in microservices, we had to go and think about the way that we used to go and test today, using typical tools like Selenium, end-to-end acceptance tests, which made the majority of our testing strategy. And we had to go and come up with new ways to get the confidence that we wanted. Again, just to make sure that we're on the same page, because this was also a learning for me when I came to Xero. On the left-hand side is what your typical monolith is. It's one big massive application that has everything inside of it. It's got your UI, your front end, which could be JavaScript, HTML, could be React, could be Angular, could be Ember, could be jQuery in some places that I've worked at until today. It's got some business logic that's maintained by many, many different teams. Everybody contributes in this one place. And you've got a data access layer, and you've got one database as well. And you've got people creating all these different stored procs and these different scripts that hook into the database directly. All of a sudden, you're choking your solution. You can't confidently modify the database. You can't modify a column name without knowing that you've broken somebody else's script. You can't modify a bit of code that does some dynamic behavior without knowing that it hasn't broken anything else that somebody else has written that you don't know about. So what we've gone with is what we have on the right-hand side, which is microservices. A small little service that does one thing and one thing only. And we do that by thinking about domains. So for example, imagine you have a CRM, and a CRM that allows you to create a contact. And this contact might be associated with a list of addresses. And this contact might be invoiced by you. Each one of these microservices could represent one of these domain entities. So you'd have a microservice that's responsible for storing your contacts. That's all that it does. You can't go to that microservice and say, how much does this contact owe me? That information is not in the contact service. There's another microservice, which is called the invoicing microservice. If you want to know anything about the contacts owing, you go to the invoicing service, you give it the contact ID, and that service is responsible for storing anything within the invoicing domain. So by breaking things down into domain, it made our conversations much, much easier. It made our design much simpler. I have teams coming to me from Wellington asking me, hey, we'd like to store this piece of information in your service. Why? Because it's very, very handy. You've got everything that we need except this little piece. Yeah, but this piece that you're asking is not part of this particular domain. So it makes the conversations about where the boundaries lie extremely easy to talk about. Now, when you talk about microservices, immediately leads to the concept of contract-driven testing. And so in this particular case, contract-driven, consumer-driven contract or contract-driven testing, the pinnacle of it is every single service that I spoke about. So if I go back to my previous slide, every single service here is almost like an API. And it's got a contract that's written literally in blood that we shall provide you the following resources. If you give us this particular key, we'll give you back this particular blob. And if we can't, we're going to give you this particular error. And if it's not found, we're going to give you this particular type of error. We actually go and document literally how the service behaves in a very verbose manner. So if another team sitting somewhere else, or even in the same city, but they're working remotely, want to consume our service, they don't even have to talk to us because we're very bad communicators in general. We want to avoid talking to each other as much as possible. So we say, hey, look at the contract. It's very well written. We test the contracts to make sure that they're always up to date, and it's our source of truth. If the contracts are incorrect and hence your system is failing, that's a different type of problem that we can try and fix. However, if you want to fetch any information, it should be on the API of the service. Now, of course, there's a lot of other challenges around backward compatibility, about versioning. These are other things that we can talk about. But the thing is, microservices and having a clear contract simplifies the conversation easily. And more importantly, in this particular example, you've got some sort of a service that my team has created, and we've got contracts that we expose to two different clients. these clients know how to talk to the service by looking at the blueprint of our contracts. These contracts are stored in Swagger, Blueprints. There's a lot of services like Apiary, and there's a lot of tools around there to help you document your contract in a way that's reasonable, that's the way that's easy to test and so on. Now, like I said, the benefit of having contractors, it makes the conversation easy. It makes defining boundaries very easy. But then the other third benefit, which was extremely crucial for us, is it allows us to contract tests. So, for example, a consumer on the left-hand side. So, for example, we've got a client web. It's an application that needs to go and surface some information about clients. It doesn't need the real service to be deployed on the developer's machine. It just needs a stub. A stub is like a lightweight fake that's running on your local machine. If you give it some data, it could echo back. The stub could be as smart as you want it to be or as dumb as you want it to be. We made very, very dumb stubs initially. And what that meant is a team that has 10 dependencies don't need to install 10 different dependencies on the local machine. They just need to go and install 10 different stubs. We use Node, and Node gives you this ability of doing an npm install. If you're familiar with Node, you just do literally a one-line command that installs all your dependencies, and they're up and running with one single line of command. You don't really have to much think about how these services are installed. Is one of them using .NET Core? Is it using .NET? Is it using Java, for example? They just mimic the contracts that you're meant to be talking to. And success for this particular application is to call this contract with the right request. We couldn't care less if the service is giving us back the right information or not. All we care about is are you sending us the right information that we require you? And that's the change in mindset that we had to go and have. So we only test contracts in our project. So we've got about 10 dependencies. We don't have any of them installed on a local machine. And all our tests in our code base is, when I press a button, did I send the right request to a remote service? I couldn't care less about that service sending out emails or writing something to the database or giving me back any data. All I care about is, have I fulfilled my part of the contract, which is send you the right information that that particular service expects. Now, because of this technique of using stubs, we started using stubs everywhere. So if you look at the left-hand side, you've got a package that we built. So a developer writes some code, builds a package, could be a zip file, could be a jar file. That developer is actually running that package on his local machine, and the local machine is completely running against stubs. We don't have any real services running on our machines. Just to put things in perspective, for me to set up all of Zero, it takes me about 3 days to set up all of Zero in a good day. You'll have things out of date, documentation not installed. For some reason, you get all these weird errors. It's because I've got a very different version of a particular dependency. It's all sort of issues that happen when you try and install all our different dependencies that we have. It takes literally 3 days. For a developer joining one of our teams working with stubs, it literally takes them 5 minutes of installing these stubs, which we've kept up to date and we've maintained, but it literally takes them 5 minutes to stand up these stubs instead of 3 days. Stage is almost like our development environment. We also have our stubs running in there. And the cool thing is we're able to go and easily stub out our personas. So if somebody from the business is preparing some educational material, they might ask, can you create a person with 10 contacts? One of them lives in the States and another lives in another place. If you were to do that in a real environment, it would take you a lot of laborious work to go and set up the data. With stubs, we just go and we create the data easily using scripts. So we can create many different personas at ease at a click of a button. And if we've got time, I can show you some demos of some of these tools that we've got. In pre-production, we generally run against the real things in pre-production. In some cases, we can't, and we run against stubs as well. So we run a hybrid in a hybrid environment. Of course, this effectively running against stubs in a pre-production environment adds amount of risk to our work. We're working against something that's not real. Okay? But then we mitigate it with other techniques that I'll be talking about. And obviously, production is production. We run against the real thing in production, and nothing can, substitute production in a production environment. You can do whatever you can in pre-production in a stage, but production is king. It's got all the data, it's got our real users. We test against the real thing in production. Now, I wanted to go and cover the testing process. What did we have to do to change our testing process to achieve continuous delivery? Here's an example. This was given to an internal audience first, so I've put in the names of real services that we have. So I've worked on the practice service. It's a service that takes care of practices. Practices are accountants and bookkeepers in zero speak. A practice or an accountant has relationships with customers. If a customer is on Xero, they're inside an organization service. So that's roughly how we are sort of set up. The practice service that me and the team built has a number of dependencies, one of which is the organization service. I've omitted all the other dependencies to make it simple. If I was to go and put a cross-section of this particular service, will be sort of what you expected. It's a RESTful service. It's got some resources. It's got a service layer that talks to a domain layer, talks to some repositories. These repositories might fetch data from a database or might fetch data via an HTTP client from an external service. So it's a RESTful API, has dependencies on disk, dependencies on other different services, nothing special. It's a very, very lightweight. Like I said, the practice service only deals with one domain, which is the practice domain. If there's anything that's not practice related, it's not in there. And it's a very easy conversation to talk about because we speak domains. So when we write our unit tests, what we made sure that we do, so this is us now working with developers. When we write our unit tests, we write our unit tests that are very, very small. And we only test small functions. We don't mock anything at all. So for example, if you have a method that goes out to a service, that service is a side effect. That service could be down. That service could return you the wrong data. We avoid mocking that particular service. So as a team, we've agreed that our unit tests need to be very, very small and need to be very simple. They don't test state. So in here, I'm trying to give you the indication that if I've got a particular layer, I have a domain, I've got a unit test that tests something inside this domain. We don't write unit tests that go across different tiers within the same service. So in my previous team, we used to write these beautiful unit tests that would go and test everything end to end and mock about 6 different things. These are the tests that I was talking about that did not give us any confidence because I had a lot of things mocked in there. I just wasn't sure if this is actually working or not. So we had to go and modify the way that we write our tests so that we test things as small units. So here's a small example. Again, if you're not technical, just bear with me. This is pseudocode, so it's not real code. On the left-hand side, imagine you've got a method that gets a list of events. It does a partner swap, it does some sort of transformation, and then it calls another service to go and create it. What we make sure is each of these functions, they take in an event. These functions don't care where these events came from. So that function is not responsible for fetching the event. Each function says, given an event, I don't know where it came from, but given an event, transform, do a swap, do a create. So we make these methods public. We test these functions. We don't bother testing or unit testing the parent function or the coordinator, the thing that coordinates everything together. We purposefully omit it, and we don't bother testing it at the unit test level. Okay? Now, we don't do that because our integration tests do that for us. Now, we don't actually do integration testing. We actually do component testing. So just so that we're on the same page, an integration test, there's many different definitions for it, but the definition that we had as a team that we didn't want to do is writing tests that went over boundaries. So for example, if my practice service talks to another service, like an email service, we don't do a test that tests everything from the practice service all the way to the email service and back. Okay? We only test within the boundaries of our service. And we stub out all our services externally. Now, we do that by making sure that our entire microservice is in memory. So we don't actually need a real environment to test our services. We actually stand up the entire environment in memory. And we can go and call our endpoint just like you would be calling it using Postman, or you'd open a browser and hit a URL. We do exactly that. And if our service needs to go and talk to an external service, we use some of these stubbing frameworks, Pact, and there's an internal tool called Chappy that we use. Pact is a great framework that we discovered recently. It's developed by Australian seek.co.nz or seek.com.au. The guys in Australia have developed Pact.net. But Pact, in essence, is actually it's actually a spec. It's a way for you to define your contracts. And Pact.net, and there's Pact.js, and there's Pact Java. They're just frameworks to stand up these mock services and allow you to go and test your stubs. Again, I might walk you through some code afterwards if required, but the principle is because we're using stubs, because we've got contracts, we're able to come up with these techniques where we don't actually have to go and talk to real services. As such, our integration tests or our component tests are extremely quick. They run within or less than 2 minutes. Acceptance testing, we're very light on acceptance tests, so we don't actually have any acceptance tests that actually go in and create data in live stage or production. Instead, what we've done is we've actually got 24/7 as a tool that we use. It does monitoring for us, so it's a SaaS product. You configure it to go and hit a particular endpoint that's publicly accessible. It logs in on your behalf from about 12 different locations, and it runs a script. It's almost like a Selenium on a Selenium service, basically, where it goes in, logs in, clicks on things that you define, logs in on your behalf, and then immediately gives you reports back on whether your uptime, your responsiveness of the page, and it tells you when your page goes down and if it's recovered. So for acceptance tests right now, we don't have a great story. We use this particular tool, and so far it's been fantastic. Every 5 minutes, this tool basically emulates one of us manually logging into our experience and making sure that certain strings on the page are available. And to us, that gives us enough confidence that whatever we just deployed 5 minutes ago did not go and break production. Because as we click that one button to continuously deploy, we don't actually go and check production. It's too hard for us developers. So we get 24/7 to actually go and monitor on our behalf. So the last point in this particular section is you've got your testing triangle. We are sticking to our testing triangle and making sure that at the bottom is your unit tests. We write a lot of those unit tests, and we write as much as possible. But we make sure that the unit tests don't have any side effects. They don't go over boundaries. They don't go and have any side effects. They literally are very, very dumb tests that do one thing and one thing only. Now, unit tests on their own do not give us confidence. Okay? We need to complement it with another type of tests. We don't do integration tests. We used to do them. In fact, some teams do. We have teams that run their integration tests and then they go home. The tests take about 8 hours to run. And guess what? The next day they come in, half of the tests have failed. Now, usually it's because of timeout issues or false negatives. They give you no confidence at all whatsoever. But 60% of the time of my testers are spent fixing these integration tests. Whenever I go to a tester, hey, how's it going? What are you doing? I'm fixing tests. So we decided not to write any of these types of integration tests at all. We don't do these kind of tests at all because they just simply don't work for us. What we do is we do component level testing where we test our components, how they all fit together, and also by stubbing out our dependencies. We have some end-to-end tests at the moment. We do them mostly manually. End-to-end tests is what's covered by 24/7, that service that I spoke to you about. It probably does 1 or 2 different use cases, so not a lot. So we can probably do a bit more work. And the last thing is exploratory. My product owner, myself, one of the developers, one of the testers will jump onto production, start clicking around just to make sure that nothing is broken and so on. So it's the combination of all these different strategies that give us a bit more confidence and guarantee that we haven't broken anything in production. And they run extremely, extremely quickly, and they give us a lot of confidence. Every single time we find a bug, we just make sure that we go and fix it, and we quickly add in a check for it somewhere in this particular triangle. Now, the next section, and we're almost there. I've got about 5 minutes. Right, okay, I've got 5 minutes. What are the testing strategies that we took as a team? Like I said at the start, we work in small, coherent increments whilst preserving functionality. So the last part is very important, whilst preserving functionality. I've got developers that will do a small piece of work, but if we deploy that to production, they break prod because it's an incomplete piece of work. So we normally go and wrap this incomplete piece of work with a feature flag to say we hide it so that nobody gets to see it until it's actually ready. A lot of developers don't think about it. A lot of developers will go and just think about the little thing that they're doing. So it takes us as a team the discipline to talk about how we go and split our work into small, cohesive parts. So our refinements had to go and talk about different things. Talk about how we're going to be delivering this feature. What are the vertical slices that we're going to be doing in order to go and deliver this particular story? And how are we going to go and test it? And are we going to go and do a big bang release? Is it good enough to go with one button that goes and runs a particular function, or do we need to go and deliver the entire experience? And also, when I say that we deploy to production many times, it's important to understand that we don't show this information to our customers. We only show when the product owner thinks there's enough value on the page that we can turn on the switch to go and allow some of our customers or all of our customers to go and start seeing it as well. We ship bugs. We ship bugs all the time. And our strategy is to ship bugs and find out about it before our customers. So we went hard on our monitoring. We monitor every single thing in our application. If we have a service that starts taking a lot of time, we monitor the amount of time and we start adding alerts to say, hey, if this starts taking a lot longer, give us an alert so one of the developers start looking at it. If there's a bug, if our JavaScript crashes in the browser, we haven't done this yet, but this is something in our backlog. We would like the browser to send a particular call to one of our services to say, hey, this particular customer just had a JavaScript error. Because right now, we have no clue how our JavaScript is performing on the page. So it's a hole that we have in the team that I'm working with. But the key part is, because we have an efficient pipeline, we deploy quickly and we fix things quickly. And it gives us the confidence to go and ship bugs. So we don't test to the nth degree. If it's good enough, we just ship it out. And we actually let our customers test on our behalf. We've got a good group of customers who are very tight-knit with Xero. So these are the Xero fans. So we have an agreement with them to say, hey, we're going to be showing you some alpha features. They're not even beta, they're alpha features. They will sometimes break. But we'd like to go and get your feedback. So we test with a very small number of users, and as we get more confidence with our work, we start increasing that number of the exposure to more customers as we go. So we expand on the number of people that have access to our features. Testing culture. Developers have to prove that their stuff works. It's not good enough for a developer to do a piece of work, throw it away at a tester, and move on to the next thing. It's the developer's responsibility to do whatever it takes to prove to the tester that his work works. It's his responsibility to add whatever tests required. It's his responsibility to have the right conversations with QA to figure out what tests he needs to write and to get the QA to review his work. It's his responsibility to push his change all the way to production and monitor it in production. And that's been a very, very key change for us. It's not the QA's responsibility to make sure that there's quality. It's everybody's responsibility, starting by the person doing the actual change or the actual work. Building on it, everybody's responsible for it. We all talk about testing scenarios from day one. We all talk about the behaviors that we want our customers to use. And what's amazing, by us talking about these things, we find so many gaps in the analysis. We start designing our software so that it's testable as well. We have in-depth code reviews. We've had people that worked at Xero and Xero wasn't for them. They feel that by having somebody look at their code and review their code, that they're being challenged, that they're not being trusted. So this environment that I'm talking about is not for everybody. We have very in-depth code reviews where somebody goes, does a small change. We ask them to do a small change, 1 file, 2 files, 5 files maximum. If there's anything bigger than that, we ask the developer, hey, do you mind if you break it down just to make it simple? And we will go through every single line and debate and talk about it. Hey, could this be done in this particular fashion? Have you catered for this particular scenario? Have you added any unit tests? Can you prove that this piece of work changes, this piece of work works? Can you write some tests for us? They're easy on the eyes because they're small. And we also learn quite a lot by having these code reviews. So it's a great learning tool. So if you have that culture in place, it's fantastic, and you just build up on it as you go. No team member is to be left out of the journey. I've worked with some teams where you have 2 developers in the team of about 6 or 8. The 2 developers know exactly how the system works, and everybody else sort of has an idea. They've heard of Event Store, they've heard of Go, they know and understand how events go from one place to another. They heard about these services that we talked about. Nobody's quite sure exactly how everything fits together except those 2 developers. And as a result, when you ask the team, when do you think you'll be done? They're like, oh, soon, I think so. Nobody actually knows how long things will take. Nobody knows about the amount of risk that's there. So what we do is we make sure that we have a shared understanding. We will slow down if required to make sure that everybody, including our non-technical product owner, understands every single change, every single deployable that we're doing to a certain extent. We don't go down to code level, but we go down to the general concepts, the boundaries, the API, and the contracts. And it gives us this shared ownership as well. So that also helps for all of us to be responsible for the code, not John who just wrote his code. We're all responsible for it. Last 3 slides, Shirley, I promise. I'm very, very close. I'm 3 minutes behind. Where does this leave the QA role? I got asked this question about, hey, you've been focused talking about developers. Where's the QA in the story? The QA is part of the story. It just happens that in my team, we didn't have a QA because we had a QA that left and we couldn't backfill them easily. But I think QAs are part and parcel of the story, and they're the main drivers for the story. The QA, I don't think, needs to be bogged down fixing tests that he hasn't written or fixing tests for something that he hasn't written himself. The QA instead could go and provide more valuable use of his time, looking at analysis of the requirements coming in, and exploratory testing, working with the developer. I've got an interesting photo here. This is Max and Kerry. Max is our developer, and Kerry is a QA that's joined us about 6 months ago. Anybody know Kerry or Max at all? Okay, that's fine. I'll talk about them. Nobody knows them. But Kerry and Max were opposite ends of the spectrum. Max is really focused in development and doesn't really like testing, and Kerry is all about working together. And it took them a while to actually start working in synergy. And I remember there's this one moment, I saw them sitting closely, beside each other. So I grabbed the phone, took a photo, and an hour later, I actually saw Kerry is the guy on the keyboard, and Max is actually looking over his shoulder. And I'm like, whoa, aren't I lucky? And I took another photo of what I just saw. So in this particular case, this is a good example of how I think a QA could fit in a future where we're working with these microservices and these very demanding times where there's new tools coming out every day. The team works together to go and be able to go and deliver the project or deliver the value to the customer. Max is a developer. He's probably got domain knowledge in development, a lot more than Kerry, but Kerry at the same time wears the QA hat. He's going to think about things that Max would not think about necessarily. Browser testing, testing things on the fringes, scenarios of things go down. We still require a QA's hat and a QA's mind, but the capacity of the QA and how he's involved in the work, I would like to challenge and say, hey, could the QA today be working on adding value on things that actually affect the customer rather than fixing tests, like I said, 60% of their time. Open to your input on the last point. And again, I just want to finish up by talking about the 3 takeaways. I've spoken about a lot of things, but if you can walk away with the 3 takeaways, I'll be very, very happy. First one is contract-driven testing. If you're in a place where you don't have contracts, you can start talking about domains. You can start suggesting talking about contracts. I think if you can get there by the end of the year, it will unlock a lot of these techniques that I'm talking about. Combinations of testing strategies to lead to a high test coverage. It's very, very important to understand that just your integration test end-to-end is not going to give you that confidence. It needs to be complementary with different techniques, including monitoring, including reporting and alerting. These are including exploratory testing of your non-technical BA or product owner clicking on the product as well. And the last thing is everybody is responsible for testing. It's not the QA's job only, in my opinion. And that's it. All right.
That's great. Awesome.
Thank you.
I think what we'll do